All right, we're going to look at some more variations of sine and cosine. This time, instead of multiplying the output by a constant, we're going to multiply the input by a constant. All right, so essentially the input to sine, I'm going to draw parentheses around it, around the bx, right? Because that is the input to the sine function. So in this case, we're taking x, whatever x is, multiplying it by a constant, b, and then we're feeding it into the sine function to get the output. All right. Now, same way with cosine, right? This bx is the input to the cosine. The b is a constant. We're taking whatever the x value is, multiplying it by a constant b, and then feeding that new value into cosine. All right. Now, the input in this case is the bx. So in this case, if we're going to start by just sketching a graph of y equals sine of 2x. So again, 2x is the input to the sine function. Now, we know the values of sine for the quadrant angles, right? For 0 and pi over 2 and pi and 3 pi over 2 and 2 pi, right? So if the input is one of those quadrant angles, it's pretty easy to calculate the sine. So that's what we're going to do. We're going to set 2x equal to those quadrant angles, all right? And then we're going to calculate what the x has to be in order to get that nice quadrant angle that we can easily take the sine or cosine of. Okay, so in this case, I'm basically going to solve 2x is equal to 0, right? And then figure out what x has to be to make 2x 0. Well, obviously x has to be 0. Okay, so again, here I'm solving 2x equals pi over 2, right? To get this x value, right? I want the x value that makes 2x equal to pi over 2. All right, so basically I just need to multiply both sides, or divide by sides by 2 to get x by itself. So I'm going to get pi over 4. Okay, you see what I'm doing? So again, I'm solving, I want 2x to be a quadrant angle, pi, and then I'm just going to divide both sides by 2 to get x by itself. So I need x to be pi over 2, and then 2x will be pi. Okay, get what I'm doing? All right, again, I'm solving 2x equals 3 pi over 2, and I'm going to divide both sides by 2, so I'm going to get 3 pi over 4, and then finally, when I set 2x equal to 2 pi and solve for x, I'm going to divide both sides by 2, and then I'm going to get x equals pi, right? So these x values will give me the nice quadrant angles that I can use to, when I put 2x into sine, right? And I know that, you know, when 2x is 0, I get it 0, and 2x is 2 pi, I get 1, right? These are just those key points that we did way back in whatever that example was, you know, example 3, right? Example 3. Those are the values of the sine of x at the quadrant angles. It's just that now I've multiplied x times 2, and I'm feeding the whole 2x into the sine function. Okay, so now we have a bunch of coordinate pairs we can plot. When x is 0, we get 0. Now when x is pi over 4, okay, now pi over 4 is halfway between, it's right in the middle there, between, let me mark it kind of in the middle. This is pi over 4, right? Pi over 4. Okay, now, so when x is pi over 4, then 2x will be pi over 2, and the sine of pi over 2 is 1, so I'm going to get that point right there. Okay, when x is pi over 2, I got 0. Now 3 pi over 4 is halfway between. It's 3/4 of the way to pi, right? So this is 3 pi over 4, and then I'm going to get -1, and then at pi we're back to 0. Okay, now this is a periodic function, so this pattern is just going to repeat, right? I'm going to be I'm going to keep repeating that pattern, right? So I could go ahead and plot some more points, but you can see what's going on here. All right, let me connect this up with a smooth curve. All right, so I connected up my points with a nice smooth curve. And that's what it looks like. Now this time I've got 2 periods graphed, but the one period occurred between 0 and pi. And then I graphed another period just to show you it keeps going, right? So essentially you get 2 periods, in the space of 2 pi, right? So it's a horizontal compression. That's the way we might describe it, by a factor of a half. Okay, so it's compressing the sine function horizontally. All right. Now what's the amplitude? That didn't change the amplitude at all. The amplitude is still 1, but now the period is pi, right? It's half of what it was before, right? Because we have that compression by a factor of 1/2. All right. So, all right. So now you can see that what's happening with that b seems to be changing the period. So let's try another example, and this time with the cosine.